We are Team 4. We,
So you just start whenever.
Yes, you guys could go ahead when you're ready.
we are Team 4, and our product name is Sentient. We'll start first by introducing ourselves. My name is Blaine. I'm originally from Omaha, Nebraska, but currently a senior at CSU studying chemical engineering. And my partners in crime are Dea, God bless, and Justin. And I'll let them introduce themselves.
Hello, my name is God Bless. I'm a sophomore in the University of Rochester, but I'm originally from Dar es Salaam, Tanzania.
My name is Dea. I'm a high school senior, and I'm from Dublin, California.
And I'm Justin, a high school senior from San Jose, California.
We'll start first by introducing our problem, which is that driving while drowsy or fatigued greatly increases your chances of getting in a car accident. And then we'll talk about the people that are impacted by this the most and some research we did about that. And then our product, Sentient, how that can solve this issue or attempt to solve it. And then lastly, we'll talk about our competition, how our product stacks up to competing technologies. Driving while drowsy contributes to the majority of car crashes, both throughout the United States and the world, and it's something that really needs to be addressed. According to the World Health Organization, 80 to 90% of road accidents are caused by, you guessed it, drowsiness and distraction, which means that the majority of car crashes are actually preventable. This issue can be traced back to fatigue and drowsiness, which when combined can cause something called microsleep. And fatigue is generally just being tired due to mental or physical exertion. And in the case of driving for extended periods of time, you would experience some mental overexertion and fatigue. And this will cause you to be less attentive and slow your reaction time, as well as inhibit your ability to make split-second decisions. And drowsiness is sort of like being in between sleeping and waking states, which is a very dangerous place to be while you're behind the wheel. This is especially common when you're driving alone at night and on long, boring roads, and usually between the hours of midnight and 6 a.m. Here we give an example of a person. Her name's Jessica, and she's a commercial driver who works at night. She drives all night, and oftentimes she becomes fatigued and tired, and her eyes start drooping, and pretty soon her eyes shut. Jessica is a perfect example of our target demographic, which would be people that drive for long or unusual hours and would be more likely to experience fatigue and drowsiness. This would be particularly young people that work shifts or are sleep deprived.
Thank you, Blaine. Now moving on to market research. Since we already know what the problem is and who our target audience is, we decided to conduct a survey to know our target user in depth. From the survey that we presented, we realized that we had more than 40, most of the people had 40 hours a week as the median value of working, and most of them were in the range of 45 to 54 years of age, and they had at least 15 years of driving experience. But however, the most devastating thing that we realized is that more than half of them had reported falling asleep momentarily once while driving. Further on the survey, we tried to get more user responses, and some of them were talking about how they have to work so many hours a week and how they had to fall asleep at some point while they're driving. And this is why we really realized that we really need Sentient. And we developed a couple of features. We presented them to the users. We had them vote on which ones should be working. And these are some of them that were presented was turning on an alarm, recommending nearby locations to eat at rest, etc., etc. We also wanted to be flexible, so we presented other options such as turning on the music, turning on cold air. So this is just to get to gauge what the user actually thinks they might need as a thing on their cars. So we learned that a lot of people who work like really, really long hours are prone to falling asleep, and it's very difficult for them to make rational decisions when they're usually tired. So this is when we actually realized how important Sentient can be to the user. So presenting to you Sentient now, Sentient is a software that can, a machine learning software, of course, that can detect drowsiness through facial recognition by prompting drivers to take precautions. we have very different features, but please note that these are just the base features. We might end up improving Sentient as days go on. Some of them have, some of these features are alarm to the driver to make them awake, cold air, recommending nearby rest stops, as well as prompting the drivers to choose a trusted individual to call. So while making this model, we collected data from the University of Texas, Arlington. We had 60 participants who were in either of the 3 states that you see here, alert or low vigilant or drowsy, and they recorded 10-minute videos of themselves. We parsed these videos into images, and then we had a total of 558 images in total. So after this, we had a convolutional neural network set up with the following layers that you see here. The convolutional layer is the first layer, which is pretty important because it's the one that takes in the images and then scans them into a few pixels so as to create some feature maps. And we pass these feature maps that are allocated to vectors with classes to the activation function. We decided to use the ELU function so that we can be able to get accurate results for this. And also we had to normalize the activations from every single layer to make sure that we can have the necessary vector transformations. After these 3 layers, we had to go into the pooling layer, which essentially just takes the results and downsamples them. We don't really want a lot of details. We just want to make sure that our model is very accurate. And on top of that, we had to use the dropout technique, which is just to select randomly neurons that we want to ignore, just so that we can make sure that our classifier can focus on few things at a time. We also had to flatten the output that is obtained from all these layers and then pass it on to the dense layer that just connected neurons to every other neurons for our classification model. And the results that we had, as you can see here, we have the accuracy of 0.5086 and the loss of negative 1.07. We know the accuracy is the number of correct predictions, or in this case, you can say that the percentage of the correct predictions that are made by a model. And the loss just defines how well or how poorly a model behaves after each iteration or every optimization based on the training and the validation sets. So this loss seems to be pretty good, honestly, but I think we can always strive to do better by increasing the amount of data that we use to train the model so as to make it less biased, of course. And we also have to add additional layers to our model just so as to increase the accuracy of our model. And you can see the graph right here on the right.
Since we had time constraints, we did not actually build a finalized model. However, this visual depicts our ultimate goal. As you can see, we'll have a system that detects the amount of drowsiness the driver displays and visually displays the statistics. As you can see, the first driver has 98% drowsiness, 5% low vigilance, and 2% alert. And this data classification comes from the data that we used. So, well, the model is only the first part of our product, and after detecting drowsiness, we intend to have a series of responses personalized by the user beforehand that will occur. Our first feature is a combination of alarm and air. Specifically, the alarm is a 30-second count that keeps on blasting in an attempt to keep the user awake. Likewise, it will prompt the user to turn on the cold air. In the future, we hope to work with actual automotive engineers to integrate this application to car applications, into car systems, so that the cold air blast can be automatic. I will now go over the sound system more in depth. Essentially, we plan to use Pygame, a Python module, to blast the alarm sound. The sound will go off when the model detects an eye aspect ratio of below 0.25 in 50 frames. As you can see in the visual, a dip represents a blink, and essentially all this means that the driver has basically shut their eyes for a prolonged period of time. Our second feature is recommending rest stops and restaurants to the driver. To do this, we plan to use Google Maps API, which has the capability to choose locations that fall under a specific description, such as a gas station or a restaurant. To pinpoint the specific user's location, we'll use IP-Info's API to get the user's longitude and latitude. As you can see in the UI, putting these two APIs together, the system will pull up recommendations based off of the user's current location. Finally, our last feature is to prompt the user to call a trusted individual based off of their context list. To do this, we plan to use Twilio, a cloud-based communication service that allows applications to make calls with ease. Using their voice APIs, we can directly add inbounded outbound call directly to our application. From our interface, you can see that the car will prompt the user to select an individual and we'll ask them if they want to call them or not. In the future, we can use an automatic speech-to-text response system so the user can physically say yes or no, and this will prompt a call automatically.
We're now going to head on to comparative analysis in Sentient's Edge. Now, when we were planning our product, we took into consideration how systems like lane keeping assistance and lane departure warnings only address the symptoms of drowsiness by correcting operation error rather than making an effort to return the driver to a more conscious state. We strive to keep driving natural for a driver instead of having automatic measures to control the car out of the driver's volition. And since we have limited time right now, we'll head over to the next slide, but please feel free to ask any questions regarding the competition matrix. Concerning our competitors, we noticed that other companies have taken an approach to this problem already, but many common systems from manufacturers like Audi and Mercedes-Benz only provide an indicator of drowsiness and provide no direct drowsiness intervention. On the other side of the spectrum, premium systems are provided with intervention, but contain unnecessary features for the normal consumer looking for no monthly subscription fees to uphold features or large upfront costs. Sentient system resides in the middle, with no additional fees, universal integration, and cheaper costs with our focus towards the essentials of safety only. Now, in the future, we plan to add more customization to disable certain solutions that will not help our niche users. And we also plan on adding more methods to detect drowsiness other than computer vision. And lastly, we'll conduct more user surveys to align to more concurrent needs. We'd like to give our special thanks to the providers of this program, SureStart, and our mentor, Hunter Best. And we appreciate your time.
Woo, thank you so much. That was amazing. Can we give them